Hello, in this video, I'm going to talk about the concept of potential divider. Not just the concept that I'm going to talk about, but also we'll solve some of the past year questions regarding potential divider to make you understand this concept better. But before I even get started, do you know why the concept of potential divider is so important? What is the use of this potential divider? Well, the name says it all. It is used to divide voltage. Sometimes when a voltage is being provided to a circuit, it doesn't mean that the circuit itself doesn't need to use that much of the voltage. So that is where this potential divider comes into play. To divide, just to use a part or the fraction of the voltage being provided to the circuit. So that is the importance of the potential divider. So let us get started. Now, potential vs potential difference. It is very important that you know how to differentiate between potential and potential difference. Do you know it? If you don't know, doesn't matter. I draw you a circuit to make you understand better. I have a circuit. I have a cell. The cell is of 4 volt. The positive terminal of the cell is being connected to 3 ohm resistor, and the negative terminal of the cell is being connected to 2 ohm resistor. So it is not about the resistor, it is about the cell itself. When I say that the cell is of 4 volt, it also means that the positive terminal of the cell is of 4 volt and the negative terminal of the cell is of 0 volt. So the potential at positive terminal is 4 volt. Potential at negative terminal is 0 volt. What about the potential difference? Okay, let me tell you about the potential difference. Different means minus. The difference between the two. The difference between the three, right? Different means minus. So how do you find the potential difference across the two terminals? Very simple. If you want to find the potential difference between these two terminals, you just take 4 volt minus 0 volt, which is also equal to 4 volt in this case. That's potential difference. So I hope you get the concept. Another example is that it is the same cell, but now this cell is being connected to 3 resistors. Positive terminal connected to 5 ohm, to 3 ohm, as well as to 2 ohm before going back to the negative terminal. So, first of all, this circuit is a series circuit. Why series circuit? What to do with the series circuit? Well, for series circuit, you have to understand that the current passing through all the 3 resistors would be the same current. It is the same amount of current that passing through 5 ohm. It is the same amount of current that passing through 3 ohm. It is the same amount of current that passing through 2 ohm before going back to the negative terminal. So in this case, current is constant. So when current is constant, recall Ohm's law. Ohm's law states that, I'm going to write it down. Ohm's law states that V equals IR. And in this case, current, I represents current. Since the current is constant, I would say that V is directly proportional to R. And in this case, V means potential difference. What to do with potential difference? It is the potential difference across 5 ohm, 3 ohm, as well as 2 ohm. I want you to see when it crosses 2 ohm. It has already uses 2 out of 10 of the total voltage. How do I know that? Because the smaller the resistance, the smaller the voltage that needed. What is voltage or the potential difference again? The work done in pushing the charged particles to flow through the resistor. So charged particles in this case is electrons. So smaller resistance, smaller hindrance, smaller blockage. That is how you think about it, right? So passing through 3 ohm, it will use 3 out of 10 of the total voltage. And passing through 5 ohm, it will use 5 out of 10 of the total voltage. Now, the concept of potential divider is as simple as when the 2 resistors are being connected in series, the total voltage that you supply to these two resistors can be shared among these two resistors. So this is the circuit diagram for a potential divider. Very simple. So the equation or the ratio of the potential divider is that you use the ratio of voltage compared to the ratio of the resistance. So I use V output, which is being measured by voltmeter, over V input, the voltage that being supplied to the circuit, is equal to, if you cannot remember, it doesn't matter. Look at where the voltmeter is being connected to. In this case, voltmeter is being connected to R2. Well, just put R2 here. V input is the voltage that is being supplied to the whole circuit. Don't you think so? That is why it is related to the total resistance of the whole circuit, which is R1 plus R2. So when you get this ratio, whatever question that comes, right? And if they ask you to find V input, they must give you the value of V. If they ask you to find the V output, they have to give you the value of V input. They have to give you the value of R2, and they have to give you the value of R1. Now, application of potential divider. I believe you have seen this before. It is being called rheostat or variable resistor. So why it is called variable resistor? It is because this is full of the coil of the resistant wire, the wire with resistance. So this is a slider, so you can move the slider left or to right in order to increase or decrease the resistance of this rheostat. So this is a circuit diagram of a rheostat. You can see that this is terminal A, which is here. This is terminal B, which is here. And C, which is connected to slider. So since C can be changed, can be slide left and right, that is why, okay, depending on how much the C is being slid, it will vary with this. That is how your resistance will be varied by sliding the C. And due to resistance being varied, output voltage will also be varied. Now, let me explain a little bit about that. What if the slider is at point A? You know that from A to B, these are all resistant wire here. When the slider is at A, so basically there is no resistance at A because it has yet to pass through all the resistant wire. So at A, I would say that the resistance at A is equal to 0. Since the resistance is equal to 0, because voltage is directly proportional to resistance, remember that? Since the resistance is equal to 0, that is why when the slider is at point A or NA, the output PD measured, the voltage reading, they will give you 0 volt. But if the slider is being moved to N of B, these are across all the resistant wires here. So the output PD measured by the voltmeter will be maximum because that is the total resistance that has been slid through slider C. Now, important thing that you should bear in mind is that this potential divider circuit can only be used in series circuit. But I know sometimes it is like most of the time, it is not just about the series circuit that's given. Sometimes they will also try to give you that parallel circuit. Are you not going to use the concept of potential divider? Yes, you still can use the concept of potential divider, but how? First, if the resistors are being connected in parallel, all you need to do is just to simplify, solve for effective resistance of the parallel circuit first and reconstruct a simpler circuit diagram, right, to become a series diagram. Then you can use your potential divider concept. Now, potential divider also being related to some of the electrical components. The very important one is the one that I put here, which is called light-dependent resistor, or in short, LDR. So do you know the function of LDR? This is the symbol of LDR. So LDR use semiconductor. LDR, it depends on light. So the symbol of LDR, you just draw a rectangular shape like this. Draw two horizontal lines at the two ends. And then since it depends on light, you have to draw arrows to hit it, because light must shine onto the LDR. Then only LDR will respond to the light. So the working principle of the LDR is that it is made of semiconducting material, which is called cadmium sulfide, which electrons will be liberated when the light is directed onto the surface of the semiconductor. And in total darkness, the only free electrons are those being shaken free or break free by the thermal vibration of the atoms. So the resistance of the LDR is quite high in darkness. So you have to remember this. In dark, resistance, I put RLDR, means resistance of LDR is quite high. But what about in light? With light or in sunlight, resistance of LDR will be low. You have to memorize this. Light energy has the effect on liberating the electrons, which reduces the resistance of LDR. That is why during the daytime, the resistance of LDR is quite low. Now, thermistor. So this is thermistor. So thermistor, I have two types. One is called NTC, the other one is called PTC. But the one that is required in your syllabus is just NTC. So this is the symbol of thermistor. I'm going to draw it up. So rectangular shape. Again, put horizontal lines at two ends. And then you just draw like a horizontal line first and horizontal line first and like that. That's the symbol of thermistor. So the working principle of the thermistor is that thermal. So thermistor related to thermal or temperature. So it is a device which resistance can vary with temperature. For NTC, right, the resistance of the thermistor decreases when the temperature increases, whereas resistance of the thermistor increases as the temperature decreases. It is opposite. So let's solve some of the one of the IGCSE physics question here to make you understand the concept of potential divider better. I will read the question. The diagram shows a potential divider connected to two voltmeters, P as well as Q. Resistance of the variable resistor is being decreased. Oh, this is super duper important. Let me highlight this first. And which row shows what happens to the reading on each voltmeter. Now, since they asked about voltmeter, if you want easy way to solve this, I just put this as V input. How about that? And V input is actually equal to, remember the concept of series circuit? The concept of series circuit says that the total voltage is equal to the sum of individual voltages. So V input is equal to the voltage across P plus the voltage across Q. And since they told you that the resistance of the variable resistor is decreasing, so recall Ohm's law. Ohm's law, yes, Ohm's law, George Ohm's. Ohm's law states that V is equal to IR. But since this case, you could see that this is what I call main circuit. You could see that the current passing through main circuit, yeah, it's the same current that flowing out from the positive terminal of the V input must flow into variable resistor, must flow into the fixed resistor before going back to the negative terminal. The one that I highlighted is called main circuit. That is the path of the current flow. Since the current, the same amount of current flowing through the variable resistor as well as the fixed resistor, current in this case is constant. When the current is constant, I would say that V is directly proportional to R. Since the resistance of the variable resistor decreases, therefore voltage P or the voltmeter readings of P will decrease. So V input is constant. Let us put in some values here to make you understand better. Initially, let's say V input is 10 volt. This 10 volt is being shed 5 volt on voltmeter P and 5 volt on voltmeter Q. Now, when the voltage across voltmeter P decreases, let's say it decreases to 2 volt here, but the total voltage or the input voltage is still the same because the question did not mention that they changed another power supply. Since the voltage input must remain constant, what happened to the voltmeter Q? It has to increase in order to balance, to get back the same 10 volt. So that is why voltmeter Q increases, but reading on voltmeter P decreases. The answer is B. I hope you understand this. If you have any question, please do comment below. Now, what about AS physics? One of the very famous questions is here. A potential divider is used to give outputs of 2 volt and 3 volt from a 5 volt source as shown. What are the possible values for the resistances R1, R2, as well as R3? So this question actually testing you on not just the potential divider, but also test you on the concept of potential difference as well as potential. So let us solve this. I try to extend this. If this is 5 volt, that means, okay, this is also 5 volt. This is 0 volt here. I would like to find the potential difference because whatever given here, the one that I wrote here, 5 volt, 3 volt, 2 volt, as well as 0 volt, they are all called potentials. Potential means the potential at that one point. Potential difference means the voltage across 2 points. See the difference? I would like to find the potential difference across R1. So how do I find it? I take 5 volt minus 3 volt. That is the potential difference across R1. What about the potential difference across R2? I take 3 volt minus 2 volt. That is the potential difference across R2. Voltage is related to potential difference. It is not potential. So what about R3? The potential difference across R3 is just 2 volt minus 0 volt gives you 2 volt. So the ratio of R1, R2, and R3, I mean the potential difference, the ratio of the potential differences across R1, R2, and R3 are 2, 1, 2. So since Ohm's law, recall, Ohm's law states that V is equal to IR, but we all know that in this case, this is where the current is flowing. Current will flow from the positive 5 volt from the higher potential, flows across R1, flows across R2, flows across R3 before going back to 0 volt. So you could see that current doesn't split. So in this case, the circuit is a series circuit. So since the current doesn't split, I is constant. So I would say that V is directly proportional to the resistance. I mean, V here means potential difference or the voltage. But the problem is, since the ratio of the potential differences are 2, 1, 2, but I don't see I get any answer from all the choices here. There is no ratio of 2, 1, 2. No worries. What you need to do? Okay, I just make the number larger a bit. When I times 2 to all the ratio, I will get 4, 2, 4. Do I not have the answer here? The answer is quite obvious, which is C. I hope by solving these past year questions, you can understand better. But if you face any problem in any of the questions, or in any of the topics, in any past year questions that you want me to discuss, please do comment below. Thank you very much for listening. And these are all my website, my TikTok channel, my Instagram channel, as well as my Facebook group. So if you're free, do join my Facebook group for free notes, PDF notes. Thank you very much for watching. See you in my next video. Bye.